Hi, welcome to Engineering Physicists. Previously, we learnt about the nature of mathematics and the origin of numbers. Today, we'll learn about the basic operations we do with numbers. In other words, arithmetic. Arithmetic is the theory of natural numbers or positive integers. It stands on the operations of addition and multiplication which are governed by certain laws. In order to state these laws in full generality, we can't use symbols such as 1, 2, and 3. The statement 1 plus 2 equals 2 plus 1 is only a particular instance of the general law that the sum of two integers is the same regardless of the order in which they are considered. Hence, to express them in full generality, we are gonna use symbols like A, B, and C. With this agreement, we may state 5 fundamental laws of arithmetic, which you may be familiar with. These are the 2 commutative laws for addition and multiplication, the 2 associative laws, and a distributive law. These laws of arithmetic may seem very simple and obvious, but they might not be applicable to entities other than integers. And you must note that here A and B are symbols and not integers. If addition is used in a colloquial sense, it is evident that the law may not hold. For example, adding sulfuric acid to water is feasible, but adding water to sulfuric acid would cause an explosion. Thus, it is possible to imagine a kind of arithmetic where one of the above laws may not hold. A concrete model for the abstract concept of integer will indicate the intuitive basis on which the laws 1 to 5 rest. For better understanding, instead of using symbols like 1, 2, 3, let us denote the integers as number of objects in a collection. Let A and B be the number of dots in each box. Then the operation of adding two integers can be done by placing the boxes end to end and removing the partition. Similarly, the operation of multiplying A and B can be done by arranging the dots in the two boxes in rows and forming a new box with A rows and B columns in it. Using these two ideas, we can represent all the 5 laws. For example, the distributive law can be represented as follows. Basis of the definition of addition of two integers, we may define the relation of an inequality. B is greater than A means a box B may be obtained from a box A by adding a properly chosen third box C, such that B equals A plus C. When this is so, we write C equals B minus A, which defines the operation of subtraction. Addition and subtraction are said to be inverse operations, since when D is added to A and then subtracted from it, the result is the original integer A. Slightly extend the domain of positive integers represented by boxes of dots by introducing the integer 0 represented by an empty box. If we denote this empty box by the usual symbol 0, then according to our definition of addition and multiplication, A plus 0 equals A and A into 0 equals 0, where A is any integer. Now, A plus 0 equals A. So 0 is the additive identity element for A, since adding 0 to any integer A does not change its value. Similarly, the multiplicative identity of A is 1, since 1 into A equals 1. Geometrical models like these boxes and ancient abacuses were widely used for numerical calculations in the late Middle Ages. Later, they were replaced slowly by the greatly superior symbolic methods based on decimal number system. Well, that's all about fundamental operations in arithmetic. Next, we'll talk about representation of integers and number system.